Hello students, welcome to Electrochemistry part 10. In this part, you people are going to study an important concept in chemistry called electrochemical series. In last session, you people studied how to calculate electrode potential of single electrodes like copper and zinc using standard hydrogen electrode as reference electrode. Using same standard hydrogen electrode, students, we can also calculate electrode potential of different half cells like gold, silver, copper, zinc, aluminum, magnesium, potassium, etc. After calculating electrode potential of various electrode systems, we arranged them in the decreasing order of respective reduction electrode potential values as shown in the table. So this arrangement is called as electrochemical series. So what is electrochemical series, students? Arrangement of standard reduction potential values of various half cell electrode systems in the decreasing order is called as electrochemical series. So in this table we have only few half cells. If you refer book, you can find more number of half cells. Okay, so in this table, in the left hand side, we have oxidized form of the species. That means species present in the higher oxidation state. And when you give electrons, it gains electron and it is converted to reduced form. Okay, let us see what are the informations that we can gather with the help of this electrochemical series. The first information that we can get, the positive value of standard reduction potential indicates the reduced form is more stable than hydrogen. For example, in the case of fluorine, it gains electron and converted to fluoride ion. So anything that gains electron is called as oxidizing agent, students. Students, please don't get confused with the term oxidation and oxidizing agent. Oxidation means loss of electrons, whereas oxidizing agent means something that gains electron is called as oxidizing agent. So here positive value indicates that reduced form is going to be more stable than hydrogen. See, in the case of fluorine, in the case of gold, in the case of silver, even in the case of copper, we have positive reduction electrode potential values that indicates that this reduced form is more stable than hydrogen. Okay, and the negative value indicates that reduced form is less stable than hydrogen. See, below hydrogen we have nickel, iron, zinc, aluminum, etc. They have negative reduction electrode potential values that indicates that they are comparatively less stable than hydrogen. Okay, now in the table it is a fluorine that has a highest positive reduction electrode potential value compared to any other species. See, this highest value or positive reduction potential value, students, indicate that the species present in the left hand side has high tendency to gain electron and it wants to be converted in the form of reduced form. In other words, they act as a good oxidizing agent. So in the table, if I ask which one is the strongest oxidizing agent, then answer is fluorine because it has a highest positive reduction electrode potential value. See, after hydrogen, we can see the values that decreases, and lithium has a highest negative reduction electrode potential value that indicates that this lithium plus ion has no tendency to gain electron and thereby convert to lithium. In other words, this negative value indicates, students, reverse. What is reverse? Lithium has a more tendency to donate electron and convert it to lithium plus ion. What, students? Lithium has a more tendency of losing electron and it wants to be lithium plus ion. Thereby, this lithium acts as a strong reducing agent. Students, don't get confused between reduction and reducing agent. Reduction means gain of electron, where reducing agent is a one that gives electron. So as I told, fluorine has the highest positive value in the table, indicates that it is a strong oxidizing agent, and fluoride ion is a weakest reducing agent. Lithium has highest negative value of reduction potential in the table, indicating this lithium plus ion is a weakest oxidizing agent and lithium is a strongest reducing agent. In other words, students, here fluorine is a strongest oxidizing agent and ability to act as oxidizing agent that decreases down the group. And here lithium is a strongest reducing agent and the ability to act as a reducing agent that decreases above the group or the column. Okay, so standard reduction potential value decreases from top to bottom, indicating decreasing oxidizing power of the species present on the left hand side, I already told, and increase in the reducing power of the species present on the right hand side. Okay. Next concept is metals with lower reduction potential value are more reactive compared to that of other metals with higher reduction potential value. For example, students, zinc has minus 0.76 value compared to that of copper that has a 0.34. So that indicates that chemically zinc is more reactive than that of the copper. Its reactivity is more. So metals with lower reduction potential value are more reactive, and as a reduction potential value increases, their chemical reactivity decreases. And the next is very important point, students. The metal with lower reduction potential value, they displace other metal ions from their respective solution which are present above. For example, see here, I dipped zinc rod in copper sulfate solution. Okay, zinc rod dipped in copper sulfate solution. Keep that solution for some time. Okay, after some time what happens? Zinc dissolves and it displaces a copper ion from copper sulfate. Here you can see that walls of the container, copper is deposited and zinc is dissolved. Why this happens? Because zinc with this negative reduction potential value acts as a strong reducing agent. In other words, it undergoes oxidation by losing electron and converted to Zn2 plus. Whereas copper with positive reduction potential value has more tendency to undergo reduction, or it acts as a stronger oxidizing agent. The Cu2 plus ion present in the solution gains electron and converted to Cu, students. I hope that this concept is clear. In the table, zinc has a negative value, so automatically zinc atom acts as a reducing agent. It is converted to Zn2 plus, enters into the solution in the form of Zn2 plus and gives electrons. Cu2 plus from the solution gain those electrons and it is converted to Cu. If I ask you the question, magnesium displaces which metal ions which are present in the table? If I ask, then you can answer. It displaces aluminium, Al3 plus ion, Zn2 plus ion, Fe2 plus ion, etc., which are present above in the table. I hope that this concept is clear. Students, sometimes they ask you a question like this: aluminium rod should not be kept in copper sulfate solution. Give reason. So same reason you have to write. So when we keep aluminium rod in copper sulfate, what happens? Aluminium that has a negative reduction electrode potential, so it undergoes oxidation, converted to Al3 plus. Copper ions present in the solution, they gain electron and converted to copper metal because it has a positive reduction electrode potential value. So that is one more point that you need to remember, students. Next very important point is the metals which are present below the hydrogen in this electrochemical series, they displace hydrogen gas from the acids. Suppose if I keep zinc rod in HCl, then what happens? solution turns to be zinc chloride and hydrogen gas is liberated. That is one more information that you can gather from this electrochemical series. And next, this electrochemical series helps us to calculate EMF of any cell. See, I can combine aluminum half cell with the copper half cell. Okay, so here copper half cell with the positive reduction potential value acts as cathode and aluminum acts as anode. I can do E cathode minus E anode and I can get E cell, EMF of the cell I can calculate. That is one more information that we can get from this electrochemical series. Thank you, students.